Hi, this is Kevin Trainer, and welcome to my lecture on state machine diagrams. This is a lecture for my systems analysis course, and so I'm going to be talking about state machine diagrams, which are part of the UML, the Unified Modeling Language. I'm going to be talking about them particularly in relation to how we're using them in our course. And the way that we're using them in our course is we're using them at the very end of conceptual data modeling. And we're using them as a way to kind of assess the goodness of the data model that we put together. So we put together a conceptual data model, and the data model is supposed to be sufficient to store all of the data about our application when the application is at rest, sort of in between transactions, if there's a time when the system's going to be turned off. And so the requirement for that is the system has to be able to remember all the data that it's eventually going to need to either to cough it up in terms of some kind of a screen or a report, or to somehow affect the system's future behavior. And, we've gone at that with kind of a brainstorming approach. And now there are a couple of techniques that we can use to say, let's just use a technique or two and see if our data model will hold up to all the tests we want to put it to. And one of the tests is to pick probably the main entity in our application. In the practice problem that we do in my course, which is at this point the iSchool web store, that main entity is an order. Okay, and in the demo that I'm going to do for you, or the example that I'm going to show you in a couple of minutes, we are it's an application that has to do with graduate school applications. So the main entity is the graduate school application. And so what we want to do is we want to track that entity in its life as it's known to our system, kind of from cradle to grave, and make sure we understand all the states that it can be in within our application cycle. And the reason is, once we get done with this, once we understand all of the states that in this case, the graduate school application can be in, and how it transitions from one state to the next, then we can go back and look at our data model and say, did I build in enough capability into my data model such that I can capture all that information? And what often happens is that you go back and you say, oh, you know what? I don't have any way to record that. This key entity from my application can have, it can be in 9 different states in the application, and I've only got a way to record 6 of them. Well, then you need a way to record another 3. Well, how could you do that? Well, the typical way that we do is that if we're not tracking something at all, then we probably are going to add attributes to some kind of entity in the data model that's going to allow us to track that fact. Okay? If we're already tracking a fact, but we don't have enough legal values for that attribute, well, then we change the assumptions about the values that attribute can take on. If it turns out that the way that we record the fact is with a relationship to some other entity in the data model, well, we might need more relationships, right? Um, so data models are made up of entity types, relationship types, attributes, etc. So, the fact is, what do we have to change about the data model such that all the states that we identified in our state machine diagram are represented clearly and easily in the data model, which is, of course, going to turn into the data store that we're going to be using. So, state machine diagrams. Let's take a look at one. I have here a resource from one of the diagrammers that we use sometimes in my class, Visual Paradigm. And this is part of their documentation. And I've made it available as a resource to my systems analysis class. And we're just going to hope that this comes up. Oh, here we are. I'm currently recording in the bedroom of my aunt's house over Thanksgiving weekend in my hometown. I've gone back to my hometown. So I don't have all my usual connections, and so things may be a little dicier than usual. Okay, so this is, let's see, this is a state machine diagram that someone has created for something. Now, one of the things that I don't like is it doesn't have any title. Okay, so for me, it would be nice to have some kind of a title so we would know that we're documenting the states of something, right? So in this case, it looks like some kind of sale is being made. It looks like it's not real different from our example. It looks like it's some kind of booking. So perhaps we're making a reservation for something, or we're booking a ticket or something. So here we are. What are the symbols in this state machine diagram? Well, in the upper left, you'll see that we have the solid circle, and that's the initial or start symbol. And in the lower right, we have two termination symbols or stop symbols, and they are the solid circle with a ring around them. Now, I just want to say that for me as a diagrammer, I would want to have one single termination symbol. I find that that's kind of the neat thing to do, because you can go from that and you can look back and say, okay, the states that should connect to the termination symbol should be the terminal states. Okay. So this sounds like some kind of concert ticket booking, right? So those are the start and stop, but I just would have one of these terminal or stop symbols, and I would have shared it between these two flows. Okay. So each of the boxes is a state that the order can be in. Let's say this looks like it's a reservation, a booking for a concert, let's say, right? So the booking is initiated, then it's created, then the payment is settled, and then it goes from there. It's either canceled or the concert is attended, and then we end. So this is a lot like a number of kinds of diagrams that we've done so far in the systems analysis course. And what I really want to do is not so much to concentrate on how this is similar to things that we've looked at, but how this one's going to be different. All right. State machine diagrams are an outgrowth of a field of study in computer science called finite state machines. And these are computing mechanisms that can only be in one state at one time. Okay, so and you get your computing done, you get your work done by moving them from state to state. An example that I like to use of this is a combination lock that you might have used on your high school locker, or that you might use on your gym locker today. Okay? Now, the kind that we used at my high school, and I'm thinking of my high school because I'm about to go tomorrow to my high school reunion. So I'm actually thinking about the lockers that I had there. The kind of locks that we had, and the kind of lock that I take to the gym today is a typical locker lock. It's a combination lock. It has a dial on the front. And typically what you do is that you turn it to the right until you get to a certain number, and then you turn it to the left till you get to a certain number, and then you turn it to the right till you get to the third of the numbers, and then you click it open, right? And so when you think about that lock, you can think of it, well, it has that sort of initial undetermined state. You come upon the lock, you don't know what's been done with it. And what we usually do is that we spin the dial to reset it so that we know that we're not in the middle of some kind of a situation where we're halfway through getting the lock open. And so then we spin to the right. And the first of the states that we get to that we're interested in is probably first number solved. Okay, and then we spin it to the left, and we get to second number solved. And then we spin it to the right, and we get to third number solved. And then we yank it open, and it's open, right? So so you can take a simple problem like that, and you can kind of explain it as moving from one state to the next. Okay, so in this kind of a diagram, you would take each of the states that I talked about, like the reset state and the first number solved state, and you would represent them with one of these rounded boxes. Okay? So if that's what the rounded boxes do, then what do the flow arrows do? Well, they do something very specific. Okay? What they do is that they tell us what action is going to trigger that state. Now, it's kind of interesting to think about that because we've done a number of diagrams so far, most notably the activity diagram, in which we have been showing actions. And although we've not been documenting the states, a lot of times the state that whatever the entity is in is sort of implicit in the activity diagram. So you can go to an activity diagram and say, well, geez, I've got most of my information right here. But what's interesting is that in the activity diagram, the actions are in the boxes. And a lot of time, some kind of comment about the states are on top of the flow lines. Now here it's reversed. Okay, if you're going to have any action, it's going to be one of these trigger actions that becomes a label for the flow line, like visit booking page, or submit booking, or settle payment. Okay, all those things are action oriented, right? And then initiated, created, payment settled, those are all state oriented, right? Um, it's sort of interesting here. They're all they're all expressed in the past tense. Some action has happened in the past tense. It was initiated. It was created. The payment was settled. It was canceled. It was attended. Right. Good. So those are all states, and the states are comprehensive. Okay. What we're trying to do is we're trying to identify every possible state that can happen. So if there's an important state of this important entity, in this case, it's the booking, okay, it has to show up in the diagram because it's really meant to be comprehensive in that regard, all right? On the other hand, the activities that we see are not comprehensive. They're not all there. This isn't an activity diagram, okay? I know the symbols are the exact same symbols that we were using for the activity diagram, so it's easy to be sucked down the hole of making this an activity diagram. The thing, if one of these flow lines has a label, it's saying what's the last activity that happens right before the change of state. It's not the only one that happens. Let's say a list of 10 things have to happen. In order for the state to change, right? We only have to tell the last one. It's a little bit like telling a ghost story. In a typical ghost story, you can draw them out as long as you like to do. So, let's say we have our the heroine of our story. She's going into a haunted house, right? And she's going to go into one of the upper floors into a particular spooky room, and she's going to open the door, and she's going to walk in, and then she's going to be in the haunted room. Okay? Well, you could tell this story a lot of ways. I mean, you could start with her waking up in the morning. It was a wonderful day. She woke up. The sun was shining. You could talk about what she had for breakfast. You could talk about, who was at the breakfast. I mean, depending on how you like to tell your story, you can really stretch it out a long way. But sooner or later, you have to get her in the vicinity of the haunted house, and she's got to get in the house, and then she has to go up the stairs, and then she has to go down the hallway, and then she has to open the door, and then she enters the room. Now, the triggering action from the state of not being in the haunted room to being in the haunted room is walked through the door, right? So that would be the action that we would document on the flow arrow in the related state machine diagram. That's not saying that she didn't wake up in the morning or have breakfast or go for a lovely walk or to talk to her sister Teresa, right? Nope. Those are just all parts of the story that we're not putting on the diagram. What would go on the diagram would be walk through door to haunted room, and then the state changes in haunted room, right? So one of the things that people get wrong a lot of times is that they want to document too much of the story in the flow lines, right? Instead of just the last action, so you can remember to pay attention. The reason it's there is that we can say, well, when does this happen? When do we have to pay attention and look for this? And it's just like, well, when she walks through the door, right? Well, here in the diagram that we're looking at on the screen, when do you have to pay attention to find out if this booking is initiated Well, it's when something happens when we visit the booking page. That's probably not the last thing that happens. Probably we click book. This is maybe not all that well written, right? Um, and then oh, well, that's probably not, because that's probably the same as the second arrow, submit booking. So that's probably when you click on the button for book. So visit the booking page. I guess they're saying that some activity is initiated, a potential booking is initiated when you visit the booking page. Okay, so take them at their word. That's what they mean. And then when you submit the booking, then the booking is created. And then it's going to hang around until you finally pay for it, which is what they mean by settle payment. And then it becomes paid. So payment settled. And then from that state, you're either going to attend the booking or you're going to cancel it. Right? Now, there's always the possibility you just be a no-show. So maybe when you look at a document like this, you go, you know what? I'm thinking that our analysis is a little short here. There's a third possible terminal state, one where we didn't cancel and we didn't attend, we just were a no-show, in which case there would be three possible terminal states. So the nature of this kind of diagram is in your thinking. You want to be thinking very carefully and exhaustively about the states because you want to document them all. You want to document them all because you want to go back to your data model and see that it can hold them all. And if it can't, then you need to spruce it up a bit. Okay? But you don't want to be exhaustive about the actions. You want to just want to show the trigger action, the thing that says, when you say, okay, it goes to a created state, well, how I know when that happens? Well, you'll know when that happens when they submit the booking. Okay, is that the only thing that happens? I don't know. There could be 25 things that happen in between initiated and submit booking, but we're only going to tell you about the very last one. The one where she walks through the door into the spooky room and boom, she's in the spooky room. So different storytellers could tell it different ways, but in this diagram, you don't get to use all your story-making skills or storytelling skills. You just get to tell the last thing. And again, if you're a person who listens to these kinds of stories and you're not that entertained by them, you're forever trying to speed up the teller and say, well, what happens, get to the action. What happens right before something important? Okay, so this is sort of a get to the action kind of diagram. Okay, let's look at another one of these, and it uses another couple of features of state machine diagrams. You will note here, okay, in the existing one about the booking, you will notice that there is a kind of a choice that goes on between whether a person is going to cancel or whether they're going to attend, and perhaps if we change it, whether they're going to be a no-show. But it's not really something that we document. Okay, so if there are two possibilities and they're not something that in this case they just have to do with the behavior of the customer and not some kind of a decision we need to make inside of our application, we're not really documenting any kind of a decision that goes on within our application. Within our application, we go from payment settled, and then the next time we get some kind of experience with our customer, they've either canceled or they've attended. Okay? And I would say the third thing that could happen would be the event could happen and no one could use the ticket, in which case it would be a no-show. Okay, so notice here that we don't have any kind of decision symbol or anything that comes out of payment settled. We just have two possible paths. Okay, Now, let's look at another sample state machine diagram. This one I put down here under other resources, sample state machine diagram. And this is the one that I told you about a few minutes ago when I said that we had a graduate school application. Okay? Now, what I've tried to do here is to document the use of a couple of things. One, decisions that are part of the application or your business process itself. Okay, in which case, instead of just having two lines that come out of a state, we're going to have one line that comes out of a state. And we're going to document what the possible outcomes of a decision are, or a choice, right? So let's look at the symbols. We have a start symbol or an initial symbol, okay? We have a stop symbol or a termination symbol or terminal symbol, okay? And again, they're the same symbols that we used for the activity diagram. So it's very easy to get seduced into thinking like activity diagrams. This particular diagram was done, I think, with Visio 2013. I don't think the stencil has changed at all in Visio 2016, which is what we're using in class this current semester. Okay? One thing that's different in the way that they do the diagrams between the activity diagram and the state machine diagram, the initial symbols are the same, the termination symbols are the same, okay? The flow lines look the same, okay? But the boxes are a little different, okay? The boxes in an activity diagram in Visio are shaded on the top, and that's where we put our description of the state. So when you look at one, you can kind of go, oh, that's not an activity diagram. I can tell by the shading that's a Visio state machine diagram. Okay, so let's look. What we're looking at is the graduate school application process. And I thought, well, what's the major entity in this process that we're trying to track? Well, it's the application itself. Okay, and it's not just the application in a paper sense. You know, when I used to apply to graduate school, you would actually send in paper. You really don't do that anymore. You just ship in a bunch of electrons. But the application is more than just a piece of paper or several pieces of paper. It's a more conceptual entity. You know, a person is applying, they're making an application for admission, and there may be pieces of paper involved, there may be electrons involved, there may be payment involved, there'd be all kinds of things, okay? So we're talking about it as a pretty big conceptual entity, right? So in my model, okay, the first time we know about the application, the first time it becomes a real application to us, because we're the school, okay? I've done this from the graduate school point of view, which is where I've more recently been, okay? When we begin, we've received the application, okay? Now, to me, that's a great initial state for us, because before that, we don't know about it. Okay? To some extent, it's real in the mind of the applicant. Okay? But until they act and we get some evidence, okay, then we don't really have an application. You know, it's perhaps an aspiration in the mind of the applicant, but it's not an application to us per se. So we begin with the state received, okay, and then we go from that state to awaiting a consideration, okay. Now, what goes on in between? Well, I have a choice here, okay, in which we're going to do one or the other. So I use the action, the process that represents the choice. I put the name on the flow into it because we don't put the names in the choice symbol themselves. And I put the words check for validity there. So that would be, do we have all the parts, right? So then, immediately after every choice, we have a guard condition. Now this is the same kind of element that we had in activity diagrams. They are tests, right? So you have to be able to pass the test to go down that path. Okay? We're going to take one or the other. They can be more than two. So we're going to take one of the bunch. Here there are two. So we're either going to go to one or the other. And they should be mutually exclusive. For instance, if you pass one of the tests, it should mean that you fail the other one. So here are my tests. Valid application, not valid application. Well, that makes sense, right? So if we have a valid application, then we're going to go to awaiting consideration. Okay? If not, then we're going to go to returned. Okay? Now, could we have put a trigger in front of return that said return application? Could we have done that? Yeah, I think that would have been okay. That's a precipitating action. All right, so that's okay. So one of the terminal conditions is we returned it. We got it. It wasn't valid. We sent something back. We probably sent them some kind of email or postcard or letter that says, hey, we got your application and it's deficient in such and such a way. You forgot to send your check for $500. You didn't sign it. You didn't include your transcript. Whatever it might be. Okay? So we go from received to returned. The alternative is that we sit here and we await consideration. Okay? And then there's some kind of process that goes on in which it gets considerations. Maybe a lot of processing that goes on right under awaiting consideration. Okay? What kind of things can happen? Well, we start to consider it. So maybe we distribute the application information to the people on the committee. And maybe, maybe we have some kind of a protocol where each person being considered gets their applications get read in depth by two of the members. Okay, and then we have a meeting where the two members present their findings to the rest of the committee. I don't know if people actually do this, but this is the kind of thing that people do in life. And then, sort of everybody hears the arguments pro and con, and then we make a decision. Okay, so the triggering event is that there's a decision. Okay. That's not the only thing that happens between awaiting consideration and the next thing, the choice. What triggers the choice is the decision. Okay? She walks through the door into the spooky room. It's the last thing that happens. We don't have to document all 25 of them. Just the last one. Okay? And then after the decision, here are the conditions that we're testing in these guard conditions. And notice proper guard conditions are in square brackets. I think I can make this a little bigger. Sorry that I didn't before. Yeah, so proper guard conditions are in square brackets. And we see that, I think that looks a little bit better. And so if it's rejected, it goes to the rejected state. If it's accepted, it goes to the accepted state. If it's waitlisted, it goes to the waitlisted state. Okay. So rejected and accepted, like returned, are terminal conditions. Okay, terminal states. How do we know that? Well, because the flow line from them goes to the termination symbol. And also, that flow line never has a label. Because how do we label flow lines? Well, generally speaking, they have either a trigger, they have on them some kind of action that's a trigger, or they have some kind of a guard condition. Or they could have both, I guess. When we get to a terminal state, we really mean a terminal state. It's done. That's as done as it can get. So if we've rejected it, it's rejected, okay? We don't have to wait for any kind of a trigger. Okay, this isn't some sort of a business process flow where we say, okay, after we make the rejection decision, we're going to send this and we're going to update that. And no, this isn't that kind of thing. We're trying to say how many states can the application be in, and are there any choices that go on, and if the choices go on, what are the guard conditions that have to be satisfied to go to a certain state, and what triggering actions are interesting. But there can be no triggering action to leave a terminal state. It just is terminal. It's just over. The fact that it's over is expressed by a flow line that goes to the terminal symbol that doesn't have anything on it. Now, so we can go to rejected or accepted or waitlisted. If you're waitlisted, that's not a terminal state. Okay? Really, what happens is that at a certain point, it becomes ready for consideration. Okay? Maybe when we waitlist people, we don't reconsider them for another, maybe they just go right back into the batch. Or maybe we look at them again in a month. Or maybe we look at them again, maybe we look at our acceptance process as having 3 phases. Sort of early acceptance, normal acceptance, late acceptance, right? So maybe you have to wait for the next phase to start, whatever that is. Okay, so there's some kind of a triggering action where it becomes ready or ripe for consideration, and then it just goes back into the pool of awaiting consideration again, and it has to have a determination. Eventually, all these are going to wind up in some terminal state. Okay, rejected, accepted, returned. Okay, and you might want to say, well, aren't the returned ones really rejected? And I would say no, not really. They haven't, they never got to go through the whole process, right? So they never really went through the process. So I think that's really a third terminal state. Couple of considerations here. The one that I mention all the time is that there should be no triggering actions on the flow line between a terminal state and the termination symbol. Okay, that's what makes it a terminal state, right? The other thing is that I think I used to say that I didn't want to see any trigger actions between the start and the initial state or initial states. And I'm going to say that it's okay to put a trigger action there if you just want to document. You know, what action happens right before the initial state? Okay. Okay, you can say what that is. Okay, but it is okay to me, and probably consistent with my personal style, that with the way I come up with the names for the initial state or states, you know where they came from. Okay, we just received it. So, do we put a trigger action here, receive application, and then, the state is received? Okay, you could do that. That's not really my style. So you could do it either yes or no. But this issue of trigger actions being listed on these flows to the termination, this is a big issue for me, because what a lot of people do is that they'll put some kind of a trigger action on there that implies yet another state that they haven't really documented. Some kind of real terminal state that doesn't have a box. No, put it on there, give it a box. That's how you're sure that these are really terminal states. So that's a big bugaboo for me. When you're done, you want to look at this. If you're using the diagram the way that we are within the systems analysis course, is you want to take a look at this, and then you want to say, okay, can I tell about my application when I look in my data model? Is there a way to tell that it's been received? If not, I've got to come up with one. Is there a way to tell that it's currently awaiting consideration? If not, then I've got to engineer that capability into the model. Is there a way to tell that it's been waitlisted? If not, then we need to add that. Is there a way to tell if it's either rejected, accepted, or returned? If not, we've got to add that capability. So, some people use these kinds of diagrams to work on their program logic, all kinds of things. With us, it's data model sufficiency. So you ought to be able to take a good state machine diagram for the key entity or a key entity in your application, and you should be able to take it and go back and either confirm that you did a great job on your data model, or realize that you need a couple of other features in order to track all the information that you need to track. And that's probably more likely. You've probably come up one short. I know for me, I did this. I actually had a data model for this, and I got back and I didn't have a clear way to see that something was awaiting a consideration. Okay? I had the other ones were all pretty well checked. Now, I want to tell you this, okay? What I'm not saying about your data model, I mean, really listen up here, because I'm not claiming that you should add an attribute to your data model called state. Okay, this is very appealing to beginners. Okay, so you say, well, we need to know the state of the application. That sounds like an attribute. Okay, so you say, okay, I'm gonna have this attribute called state, and it's gonna have the following legal values: received, awaiting consideration, returned, rejected, accepted, waitlisted. Is that how we want to do it? Well, it's a pretty naive way to do it, it turns out. One of the things that we want to do in our data models is that we want to not carry redundant information. Okay? Why don't we want to carry redundant information? Well, because you always have the possibility that redundant facts will get out of sync with each other. Okay? So, we're not saying that you need an attribute on your data model called state, and it needs to be received. We're saying, and one of the valid values has to be received. What we are saying is you have to be able to look at your data model and answer the question in a straightforward way. How could you determine if it was in that state? Okay, so for instance, to know if an application is received, you might just have to look at the application entity, or what eventually becomes a relational table, and see if you have an instance for this application, or which in relational databases say, is there a row in the relational database for this application? If it's there, okay, fine. Awaiting a consideration, okay? It may just be that we're going to consider something awaiting consideration if it's been received and it hasn't been returned, rejected, accepted, or waitlisted, right? And then what some people do is, if they really want to say, wow, we always want to do this the same way, they create some application code in their when they're doing their programming that will look at the data model and will answer the question, what's the state? Okay? So to make sure that all the code in their system uses the same criteria for deciding what's received or what's accepted, okay, what they might do is write some common code that they share in a object-oriented programming language in which you can ask about an application object, what state it's in, and you'll get back a definitive answer. Okay? It's not going to come, if it's well designed, it's not going to come from some attribute or data element that has these exact values and is called state. It's going to come from somebody poking around in the data store, interrogating the values of various things and saying, oh, yep, it's reached the criteria that we can say it's received. It's reached the criteria where we can say it's accepted. Okay, so the question is here not, do we have the attribute called state that has these exact values, but can you noodle around in your data model as it's embodied in the data store and definitively answer the questions that are posed of, can we tell what's in that state? And if you can, you got everything you need. Okay? Adding an extra attribute called state that would take on these exact values would create redundant information that could easily get out of sync, right? So you could have the formal state attribute say one thing, and if you looked at the facts in the data, they would say something contradictory. So that would be a bad idea, even though it seems like it may be a good one. So these are state machine diagrams. They do have several uses in systems analysis and in systems design and programming. But our use is going to be evaluating the sufficiency of the data model, and I think we've done a pretty good job of kind of explaining how that works. So good luck in using this yourself, and I'm going to say bye until next time. Bye-bye.